My name's Semmens and this is Katrina, Elliott, and together we've been working on the Year 7-8 STEM Collaborative Inquiry project. That project has brought together 39 schools across South Australia, and all of those schools are working together to design, trial and evaluate innovative STEM learning.
We have external evaluators from the University of South Australia who are looking at all of the schools that we're working with and finding out what are the principles that make effective STEM learning.
One of the big parts of that, I think, has been exploring the ideas between inquiry-based learning and problem-based learning. They're two terms that we use a lot in STEM and in our education in general, but they can be really different and really related. So a big part of our work has been exploring that space with the educators and the students to see exactly what we mean and how we can do inquiry-based learning, problem-based learning, and both of them together to get some really impactful practices to improve the achievement and dispositions of our learners.
So what we've noticed, so someone was doing a water problem and they wanted to make clean water. So the teachers thought, right, we're going to use a problem-based approach. I want you to develop a water filter that will filter the water and get the water clean. And I said, but how do you know what's polluting the water? Where's your inquiry? So first of all, you need to think about, why don't you take the kids to go and notice the water and say to them, why don't you drink that water? And they'd probably say no. And say, well, why wouldn't you drink that water? What do you think, what's wrong? And so get them to identify for themselves and notice that there's an issue in being able to just drink that water out the creek. And from their inquiry, finding out what it is that's causing the water not to be drinkable, then you can move to the problem solving and thinking about how can I design a solution to this problem. Otherwise, it can be like the teachers already thought about what the filter's going to look like, and actually the students are then trying to guess what's in the teacher's head and what do I have to make to filter the water, because they've already given too many instructions or too much information. So to make it more engaging for the students so they can personalise and see the value in why they would even want to solve this problem, you need to have that inquiry and get them to be noticers so they value the learning.
Students are often given this task of designing a Mars rover, and the limitations in that is the Mars rover exists. We've got an idea in our head what it looks like because we've seen it, and the problem is design a Mars rover. There's no real problem there. We know why the Mars rover's already been invented. Now students go away and they kind of recreate it, and they're putting together a concept that they've already got in their head. Now, if we shift that to a problem and we say, how might we transport X around Mars? And the students will have to think about how they would do it. They might land on the Mars rover, that's fine, but they might come up with a bunch of other systems that they want to explore themselves. They might look at magnetic power, they might look at, can we work with solar, they might look at a train system, they might look at monorail, they can look at take this learning to wherever they want, which is a big shift from being told, make a Mars rover because that's a problem that somebody's already solved. So that point of difference, I think, is really important, where we give students the freedom to try and explore and come up with a product that they choose. And that can be scary for the educator because they're not sure where this is going to go and what it's going to look like.
Yeah.
But when we shift our thinking, it's going to be a lot more valuable than us grading a lot of Mars rovers that we expected to see in the first place.
Because one of the things that we often see when people have that problem-based learning, the teacher places the emphasis on the assessment of the product and not the thinking that's been involved along the way and the processes that the students are going through to get to that product. And as Alex has taught me really carefully, that you might not ever get to that end product, but what has happened in the thinking, in the understanding, the ideation, the prototyping, before you get to the end point, that's really important in problem solving. If you only include the problem-based learning, there's a good chance you won't include like some deep thinking in the maths, the problem solving and the reasoning from the mathematics inquiry won't be included in the product or the process that you're going after. The same as the science. The science inquiry skills are a very important part. So I think if you use both the inquiry approach in connection with the design problem-based approach, you will actually be able to see the science, the maths and the technology, and the deeper learning will be evident and be articulated when the students are giving the analysis of what they've discovered or, produced. I think it's linking that into the career pathways. If we want our students, we know that the routine jobs are going, the National Bank is getting rid of 8,000 routine jobs. So we know that we have to prepare our students for the future, and in the future the jobs are more about non-routine, so they have to develop those skills, the capabilities, the dispositions to be able to deal with the unknown. So that's why it's about teachers giving them the opportunity to be their own inquirers, to actually be the problem finders, so they actually can investigate and do the thinking rather than the teacher doing the thinking.
Yeah, and it's a concept that can follow our students all the way from the early years of learning through to their senior schooling. We know that instinctively our early learners they ask questions. Our 4 and our 5 and our 6-year-old learners will ask us a lot of questions. And as educators, we need to ask them the same question back. Why is this? How is this? Why is this? Well, you tell me. And it's that same position that we need to carry through all the way through their learning, but by providing them with the skills and opportunities and understanding the processes to actually find their answers. And that's a big difference of why is it like this, and you tell them and then they go and research it and tell it back to you. That doesn't serve any purpose.